Alright guys, bear with me. I'm trying to do this from home and my microphone wouldn't work, and I know this sounds a little odd. I think it does anyway when I hear it. But you can hear me and you can understand me, so just bear with me. I want you guys to go through this. I'm going to give you a couple days to do that because with our shortened class periods, I think it'll take you that long. When you guys get the test, then you can use this to help you with that test because you can use anything you have. You just can't use each other or a human being. So, number one, it says the relationship between the number of moles of two substances in an equation. That is going to be C, your mole-to-mole factor. And remember that we always get those numbers from our equation. The amount of product obtained from a reaction, that's what you actually made, what you're getting out of it. So that's going to be your actual yield. B, maximum amount of product that can be produced. So that's like, in theory, I could produce this much. So that's going to be your theoretical yield. And I do want you to change, like if you have the wrong answer, change it, put the right thing down, pause this if you need to, if it's during a math problem. Like I said, you could use this to kind of help you with the test. Number 4, the reacting substance that is used up during a chemical reaction. Well, if it's used up, that is your limiting reactant, or sometimes they call it limiting reagent. And then number 5, the ratio of the amount of product actually produced compared with the theoretical. Well, there is only one left, and that is E, and that's our percent yield, and that's just, like I said, the actual over theoretical. All right, so on 8.1, and bear with me here too, I'm usually able to write with my marker on the board during this part, but I don't have that. I just have my laptop. So in 8.1, we're going to use the equation to answer the following questions. So if I have 2 moles of C3H8, and I want to know how many moles of O2. So I'm in moles, and I want moles of something else. It's going to be a one-step problem. So let me maybe do the markup here. Text highlighter box. Maybe it's drawing that I need, guys. I'm sorry. Okay, so I'm going to try to write this here. So if I have 2 moles of CH, so this is really going to be, I'm not writing the C3H8, I'm just going to write CH because it makes it a little bit easier on me. And do parentheses. So I'm going to put the moles. I'm just going to write M too. And this is the CH. And I want to get to moles of O2, so I'm going to write moles M of O. Oof. All right, so if it's a mole to mole, I'm going to use my equation. So the C3H8 right here, there's 1. My oxygen is 5. So all I need to do is 2 times 5, and that's going to be 10. I'm not labeling this because, like I said, this is a little challenging here. So what happened is my moles of C3H8 canceled out, leaving me with moles of oxygen. So 10 moles of oxygen. All right, on B, how many moles of CO2 are produced when you have 4 moles of oxygen? Once again, it's moles to moles, so it's going to be a one-step problem. So I'm going to write 4 moles of oxygen. I'm going to do my parentheses. Let's see, I'm going to be my moles of oxygen have to go on bottom. I might be able to do this a little bit differently on the next one now that I'm thinking about it. And I'm going to do moles of CO2 on top. Alright, so once again, I'm going to use this equation up here. So moles of oxygen are 5. Moles of CO2 are 3. Alright, I'm using my phone as a calculator, which I'm not really used to doing. So I'm going to do 4 times 3 divided by 5, and that is 2.4. 2.4 moles of CO2. All right. Okay, so this next one, I'm just going to put the parentheses. It is still a mole to mole, so we're just going to have one set of parentheses. So I'm going to go ahead and draw my parentheses out. But now I'm going to see if I can do a text box. Okay, so what I'm starting with here is 3 moles of O2. I think I can even get that subscripted there, I believe. Yeah. All right, so I have 3 moles of O2 on the outside of my parentheses here. So on bottom, I'm going to have moles of O2. And on top, I need to get to moles of C3H8. Okay. So mole to mole, once again, I'm going to use this equation up here. So oxygen is going to be 5. My C3H8 is going to be 1. Again, those numbers are coming from my numbers in front, or called my coefficients. All right, so this is going to equal 3 divided by 5. Let me get my calculator back out. And that is 0.6 moles of C3H8. All right, and then on D, this last one, for this one, let me go ahead and do my parentheses. Do text box here. All right, so I'm starting with 0.5 moles of C3H8. So moles of C3H8 are going to have to go on bottom. And then it's on top is what I'm looking for. And they have molecules on here. I'll go ahead and do molecules, but we won't have anything like that on the test. We would have to go moles of H2O. So normally this is where we would go, and maybe I would ask you for how much this weighs in grams, and we would have to do a second step. Molecules is something we did back in Chemistry 1, and that was so long ago, and then COVID happened. So normally if we would have gotten to this last year, then yes, this might have been a problem, but it's been so long, we're not going to do it. So this is 1 mole to mole. I'm still going to use my equation. H2O is 4. So this equals 0.5 times 4, which would be 2 moles of H2O. All right, now if we truly were finding molecules, I'm going to do this. Like I said, you will not see anything like this on the test. We would just stop here. But since this said molecules, if we were truly finding molecules, ooh, a little crazy with that one, I would put, let's start it here. I would put 1 mole of H2O on top. Molecules would be the 6.022 times 10 to the 23rd. And then you would take 2 times 6.022 times 10 to the 23rd. So anyways, that's where the molecules are coming from. Like I said, don't worry about it. All right, so that takes us down to 8.2. So consider the equation for the following questions. Now, this is where they're going to add some 2 steps into this, maybe 3 steps. So the first one, and I'm going to write this at the top here. Remember that we can go from grams of 1. Here, I need to do arrows that go back and forth. And I can go to moles of 1. Now, this is whatever they're starting me off with. That's what 1 means. this is how I switch over into a new substance. And then I can figure out how much that new substance weighs. Alright, so remember that anytime I'm in grams, I'm going to get that from the periodic table. Anytime I'm going from moles to grams, this is going to be 1. And then right here, my mole to mole step, I'm going to use the equation. Alright, so once we have that, I am at 4 moles of my starting. So I'm always going to be either in grams of 1 or moles of 1. That's always how I'm going to start off. Well, I'm in moles of 1. They want to get to grams. So I'm going to go 1 step, 2 steps. Alright, so let me go ahead and do 2 parentheses here. Alright, so I'm going to start off with what they gave me, and they gave me 4 moles of C2H6. Alright, so that means that my first step is going to be a mole to mole, so I'm going to be using the equation. So I'm going to look up here at my equation and see that I've got 2 moles of C2H6, getting that from right here. And now I need to switch over to oxygen. So there's 7 moles of oxygen in that equation. So I'm going to write 7 moles of O2. Alright, so right now these two things have canceled out, so I'm going to now do the second step from moles to grams. And remember that it's always 1 mole of whatever you have. And then up here I'm going to use my periodic table. And what is this for? O2. So O2 is 32 grams. So this will equal, let me get my calculator out here. I'm going to take 4 times 7 divided by 2 times 32, and that's 448 grams of O2. All right. Now B is going to be a 3-step problem. I know that because they're starting me off in grams of my original right here, and they want grams of my new stuff, which is way down here, so it's a 3-step problem. All right, so I'm going to go ahead and do 3 parentheses. Ooh, oh my goodness, guys, I'm sorry about that. Whew. Alright, so I'm going to, out here on the side, I'm going to write 115 grams of O2. So on bottom is going to be grams of O2, and you're using your periodic table, and that weighs 32 grams. That's always in 1 mole. So now I went from here to here. Now I've got to do a mole to mole. I'm going to use my equation. I know that moles of O2 has to go on bottom. So I'm using that equation, and I'm seeing that I have 7 moles of O2. Now what goes on top is what I'm looking for, and this is C2H6, or ethane gas. So I'm going to use my equation. I see that there are 2 moles of C2H6. So right now my grams have canceled out, my moles of O2 have canceled out. I need to put my moles of C2H6 on bottom. And it is going to be 1 because I'm doing moles to grams. It's always 1. Alright, bear with me too, because I do not have a periodic table with me at the house. I know I could look one up real quick, and I may do have to do that here in a second, but carbon, it weighs 12, and there are 2 of them, so that's 24. Hydrogen weighs 1, there's 6 of them, so that is going to be 30 grams. Alright, let's see what all this equals. 115 divided by 32 times 2 divided by 7 times 30. And that is 30.8 grams of C2H6. All right. Let's look at C. We've got another grams to grams. So it's going to be another 3 set of parentheses. Remember, guys, if you ever need anything, like, I'm always got my phone out. It will notify me if you send me something. If you're not understanding something, just have a question. Feel free to let me know. Okay, so on the outside of this one's going to be 2 grams of CO2. I'm going to put grams of CO2 down here. Now, oxygen, we know O2 weighs 32, and carbon is 12. So that's going to be 44 grams of CO2 and 1 mole of CO2. All right, always going to start with this. Now, moles of CO2 go on bottom here. Got to look at my equation, though, and that is 4. So 4 moles. Ooh, fingers on the wrong key. CO2. I want to get to C2H6, ethane gas, and that is 2. All right, now on bottom here is going to be my 1 mole of C2H6. And we saw up here where that weighed 30 grams. All right, so that equals, get my calculator out. All right, so 2 divided by 44 times 2 divided by 4 times 30, and that is 0.68 of C2H6. All right. D has me going from moles to grams, so it's going to be a 2-step problem because I'm starting off in moles of 1, and I gotta go moles of 2, then grams of 2. Whew. All right, so 2 steps. Okay, so let's start with our 2 moles. C2H6. Ooh, running into that. All right, so on bottom, it's a mole to mole. So, right, I'm not going to use the 1 mole here, right? If it's moles and I'm doing a mole to mole, I've got to use the equation. So for C2H6, if you look at your equation, there are 2 moles of C2H6. And I want to get to CO2, and there are 4 moles of CO2. All right, now I'm mole to mole. So now I'm going to do my moles to grams. So that means it's going to be 1 on bottom. And CO2, I believe, was 44 grams. Yep. There we go. Equals. All right. 2 times 4 divided by 2 times 44 is 176 grams of carbon dioxide. All right, here's another gram to gram, so it's going to be a 3-stepper. I'm going to kind of walk through these a little bit quicker to make this video not as long. And you can always pause it if you need to at any point you want. I know, these are amazing. Parentheses. There we go. All right. On the outside here, I'm going to have 82.5 grams of O2. Oxygen weighs 32 grams. That's for 1 mole. Now's my mole to mole. Need to look at my equation, because I don't remember it's 7 for oxygen. And I'm trying to get the ethane, which is 2. Now I'm going to do a moles to grams again, so it's going to be 1 mole. And we said that the C2H6, we say 30 grams, I believe. Okay. So I'm going to take 82.5 divided by 32 times 2 divided by 7 times 30. I get 22.1 if you round. All right, the last one here. How many molecules? Once again, it's this molecules. I'm going to go from grams to moles. Guys, I'm taking you guys through like a 4-step problem here. So let's go from grams to moles instead. All right, so grams to moles means that it's going to be a 2-step. Like I said, on the test, there will not be any molecule questions. All right, so out here we're going to do 25 grams of O2. We know the oxygen weighs 32 grams for every 1 mole. And now here's my mole to mole. I know that there are 7 moles of O2. I'm getting this from the equation. And water, I forgot. I'm not sure. Water is 6. Okay, so this would be 6 moles of H2O. So the answer to this, if you're just finding moles, is 25 divided by 32 times 6 divided by 7, and that is 0.67 moles of H2O. Now, if you wanted to find molecules here, you would then say, okay, for every 1 mole, there's 6.022 times 10 to the 23rd particles. But like I said, I'm not even going to do that because it's not something you need to worry about. All right, on 8.3, how many grams of CO2s can be produced from the reaction? So anytime you see how much can be produced and you have 2 numbers, that's asking you really what is limiting you. So it's like having 2 problems in one. Now it says how many grams. Okay, so we do have to do a 2-stepper because it's asking for grams. If it didn't ask for grams, we could just do a mole to mole and figure out how much we're going to make. Okay, so it's like having 2 problems in one. So here's my first one. I'm going to put my second one down here. Okay, so for the top one, I have 2.20 moles of CO. And then for this one down here, I've got 3.60. Whoa, what just happened? Sorry, guys. I have 3.60 moles of sulfur. All right, so I'm going to start with the top one first. Okay, so this is my mole to mole, 2 moles of cobalt. And I want to know how much cobalt sulfide I'm making. I'm really going to have to pull up a periodic table here in a second. All right, so there's 1 mole of CO2S3. So then when I'm going to do moles to grams, it's always going to be 1 mole. All right, I'm going to have to put grams up here. I'm going to have to see what that is here in a second. I'm going to go ahead and fill in the bottom of this one. All right, so for sulfur, use your equation. There's 3 moles of sulfur. Once again, we're always trying to find product. There's still just the 1 mole of the CO2S3. Down here, 1 mole CO2S3, because I need to figure out how much that weighs. I'm going to find a periodic table on here. Alright. Just need to find one here. Okay, so cobalt is 59, and there are 2 of them. Okay, so that's 118. Sulfur is 32. Just checking to make sure. Yep, 32. And there are 3 of them. So altogether, that's 214 grams, I believe. Alright, so now let me get my calculator out again. I've got 2.2 divided by 2 times 214. So that's going to be 235.4 grams. This one down here is going to be 3.6 divided by 3 times 214. Ooh, they're close. 256.8. Okay, so you're going to go with the lower amount. All right, so this one right here. I thought it would let me highlight it. But anyways, this one right here is, no, it's not going to let me. The 256 is your answer. You will make 256.8 grams of cobalt sulfide, and then you'll run out of sulfur, and you won't be able to make any more. Okay, so you'll never be able to make 235 because you'll run out of sulfur first. Alright, so let's do this one down here. It's just like this one, only they're starting you in grams. We started in moles up here. They're starting you in grams here, so let's go ahead and do a 3-stepper here. Oh my goodness. I'm never going to want to make parentheses again. Alright. Phew. Alright guys, so I got 32 grams of NO. And nitrogen monoxide weighs, let's see here, it's 14 plus 16, so 30. That's always in 1 mole when we're dealing with grams. Okay, so now I'm going to use my equation to get these next numbers, 2 moles from the equation. And it's also 2 moles of NO2. And then 1 mole of NO2. Let's see, 32 plus 14. So you have 2 oxygens at 16 apiece, and then you got your 14 for your nitrogen. That's 46 grams. Okay, so that's going to equal 32 divided by 30. The 2 over 2 will cancel out. This 2 over 2 here is going to cancel out. So this ends up being 49.1. All right, let's do this next one. 24 grams of O2. We know that oxygen weighs 32 grams. 1 mole of O2. Okay, now here comes the mole to mole. We're going to use the equation. 1 mole of O2. There is still 2 moles of NO2. You notice these last 3 things that I'm filling out will always be the same. 1 mole of NO2. It's going to be 46 grams of NO2. Alright, so let me do this. 24 divided by 32 times 2 times 46. That is 69. Ooh, hello. What is going on here? All right, let me try this again. There we go. All right, so if you were to answer this, you would say 49.1 grams is what you would make because you would run out of nitrogen monoxide. So oxygen, there's enough to make 69 grams, but here you're only going to make 49.1 before you run out of some of your ingredients. All right, let's do 8.4. So this is going to be if 60 grams of H2S reacts with sufficient oxygen and produces that. What is the percent yield? All right, so you actually produced this 45.5. So this is going to be your actual. You don't have to do anything with that. So I'm going to do 60 grams of H2S, and I've got to do a 3-step problem to get to grams of SO2. It's always, section 3 and section 4 was always about getting to your product. All right, so 32, this is going to be 34 grams. This is in 1 mole of H2S. I'm going to use my equation here. Here comes my mole to mole. And I'm getting SO2. So this really just cancels out right here, this step. 1 mole of SO2. 32 and 32, so that's 64 grams. All right, so this is going to be, in theory, this is what we should have made. We take 60, no, not multiply, 60 divided by 34. This 2 over 2 step really just kind of cancels itself out. I'm going to multiply by 64. So this is 112.9 grams. That's my theoretical. So then percent yield is actual over theoretical. So I'm going to take 45.5 and I'm going to divide it by 112.9. Actual over theoretical. And that is going to equal 5.5 divided by 9.40. 0.403 or 40.3%. All right, B. If 25 grams of O2 reacting with H2S produces, what is the percent yield? Okay, so same thing here. Produces 18.6. That is my actual. So I'm going to have to take 25 grams of O2, do a 3-stepper here. All right, text box. All right, oxygen weighs 32 grams in 1 mole. Whoa. See, it feels just like I'm in class with you when this stuff won't work right. Right? 1 mole of O2. All right, now I've got to use the equation. So there are 3 moles of O2. And I want to get to SO2. So there are 2 moles of SO2. All right. 1 mole of SO2 weighs 64 grams. All right. Well, this equals 25 divided by 32 times 2 divided by 3 times 64, and that's going to be 33.33333, and that's in theory. So I'm going to take actual over theoretical, so my actual was 18.6, and divide by my theoretical, which equals 0.558, or really if you round it, it's going to be, 55.8% is what it's going to be. I just went ahead and moved the decimal places over. All right. Let's look at C real quick. We're almost done. If 125 grams of ethane reacting with sufficient oxygen produces, there is my actual. So I'm going to take the 125 grams of C2H6, and I'm going to do my 3 steps to get to grams of product. Alright. So this weighed 30 grams and 1 mole. And this is my mole to mole step, so I gotta use the equation. I'm trying to get to CO2, so that's 4. Now my moles to grams, so I'm going to use my periodic table. And this is 40. What have I done here? Here we go. 44 grams of CO2. Alright, so 125 divided by 30 times 4 divided by 2 times 44. That is 366.67. So now I'm going to take my actual over my theoretical. Divided by 366.67. Alright. 175 divided by 366.67. And that is 47.8%. Alright, here's another one. So produces 12.5. What is the percent yield of water? So I'm going to take the 35 and I'm going to go with that to do my parentheses. Ooh. Alright, text box. Okay, oxygen weighs 32 grams for 1 mole. Now my mole to mole step comes into place. I'm going to use my equation. There are 7 moles of oxygen. Trying to get to H2O. There's 6 moles of H2O. 1 mole of H2O weighs 18 grams. There's my daughter, if you could hear her. 35 divided by 32 times 6 divided by 7 times 18. That is 16.875. That's my theoretical. So then we do actual over theoretical, which is going to be 12.5 divided by 16.875, which is going to equal 12.5 divided by 16.875. It's going to be 74%. Alright, So that is the end of that. I am sorry that took so long. Once again, bear with me, guys. I should be back after this week. So once again, if there's any questions whatsoever, please do not hesitate to email me, ask me. My internal alarm clock wakes me up, so I'm up. Let me know if there's anything you need. All right. See you guys later.